In this class, we will discuss about principal strains and principal planes. So these principal planes are the planes on which the shear strains are zero. That means only normal strains will be acting on those three planes. In the case of a three-dimensional system, you have three principal planes. In the case of two-dimensional stress system, we have only two principal planes. So this procedure, of course, it is similar to that what we found in the earlier classes, how to find the principal stresses and principal planes on those on which those principal stresses act. Same procedure is there here also. So let us consider the strain tensor at a point. So they will give the strain tensor at a particular point, and they will ask you to find the principal strains and the principal planes on which those principal strains act. So if you know the strain tensor at a point, that means these six strain components you will be knowing. So they may give in this form, or they may give individually these six strain components. Now, just like you are finding in the procedure of finding this principal stresses, we were finding three invariants: I1, I2, I3. They are called as first invariant of stress, second invariant of stress, third invariant of stress. Here also, you have to find out three strain invariants. These are called as strain invariants. The first strain invariant is denoted by J1. Here we call them as J1, J2, J3. So this J1 is nothing but the first strain invariant of invariant of strain. That means these values, they won't change irrespective of transformation of the axis. That is the meaning of that. So J2 is given by this. So this is called as the second strain invariant, J2. So instead of I1, I2, I3, we call this as J1, J2, J3. So J3 is the third strain invariant. So by knowing these six strain components, you can find out these strain invariants. For example, J1 is epsilon x plus epsilon y plus epsilon z. If you know this, if they give in this form, you write down separately the values and then use this formula. Be careful here. Here, if they give this strain component, for example, if they give here 0.01, if they give 0.01, gamma xy by 2 is 0.01. Therefore, gamma xy will be 2 into 0.01, which is 0.02. You should be very careful. So you write down this strain tensor, equate the respective elements, then get the strain components like this. If they give directly this, you need not worry. Otherwise, if they give in the form of a tensor, you just equate the respective elements and get the six strain components. So it is very easy to remember this. So it is cyclic in order. So similar, this is almost similar to that stress invariants. Once you get these three strain invariants, the principal strains are nothing but the roots of this cubic equation. So cubic equation is epsilon cube minus J1 epsilon square plus J2 epsilon minus J3 is equal to 0. You can solve this. Once you substitute these values, you get an equation, cubic equation. You can solve using the calculator. You will get three roots for this equation. The first value is epsilon 1, second value is epsilon 2, third value is epsilon 3. So they are the normal strains or they are the principal strains. So these three, so you can easily find out they are the roots. So you may get positive value or negative value. If the value is positive, then it is tensile strain. If the value is negative, it is compressive strain. It can have any value. We are not bothered about that. Now, once you get these three values of principal strains, now second step is they will ask you to find the principal directions. So these planes are directions. Then I call it as directions also. So normally these principal planes are defined with respect to direction cosines. DCs. Direction cosines already I have explained. L, M, N. They are the direction cosines of any plane. So L is the angle, cos of the angle between x-axis and the plane is L. Cos of the angle between y-axis and the plane is M. Cos of the angle between z-axis and the plane is N. Since here we have three values of principal strengths. For each value of principal strength, we have to compute the values of DCs. So, for example, for the first one, so this epsilon 1, this will be acting on one plane. Principal strain epsilon 1 will be acting on one plane. Now we have to find out the direction cosine of that plane on which that epsilon 1 is acting. So there I call them as N1, M1, N1. Now the procedure is very simple, like this, similar to. So please note that this procedure is similar to or the same as that of finding DCs of that principal stress plane, that is sigma 1 plane. So what we have to do is we have to consider this strain tensor whatever is given. So subtract the value of epsilon 1 from the principal diagonal elements. From the principal diagonal elements means from the normal strain components. We have to subtract this, and remaining terms remain the same. Other terms remain the same. After getting this matrix, what you have to do is you have to find the cofactors of the first row elements. I have explained this in the problem which I did for principal stresses and principal planes in the earlier class. You can just go through that. The procedure remains same. So A1, B1, C1, they are the cofactors. For example, if this is the first row elements, so A1 is the cofactor of this first element. Cofactor of this means I have to delete this row and this column. Only these four elements I have to write, and I have to find out the determinant of that. Determinant of them will be this into this minus this into this. That is the value A1. Then B1 is the cofactor of the second element. So second element you have to take minus, because alternative plus minus sign will come here. In the determinant, it will be like this. When you are writing cofactor, you have to follow this sign convention for the cofactors. So for the second one, you delete this column, this row, this and this will come minus of that. So minus of these four you have to write in the form of determinant. Then take the value of the determinant. Determinant value is this into this minus this into this. So product of principal diagonal elements minus product of secondary diagonal elements is the value of the determinant. So that you get B1 value. Then C1 is the cofactor of this third element. Delete this column, delete this row, this and this you have to write, and it is plus here. So take the value of the determinant, this into this minus this into this. That is the value of C1. So like you can go through that problem which I have done in the earlier class for finding principal stresses and principal planes. Now once you get A1, B1, C1, you find out a constant K1 which is root of A1 square plus B1 square plus C1 square. Then the direction cosines are given by L1 is given by A1 by K1, M1 is given by B1 by K1, N1 is given by C1 by K1. So these three are the DCs of epsilon 1 plane. Please note that epsilon 1 plane. So one check is, so the sum of the squares of these DCs, that is N1 square plus M1 square plus N1 square will be equal to 1 always. You may get 1.01 or 0.99, something like that, doesn't matter. So that is a check. So sum of the squares of the DCs of any plane will be equal to 1. Now similarly, we can find out the direction cosines for the other two principal strains, that is epsilon 2 and epsilon 3. So epsilon 2 value we have got here. So this epsilon 1 already we have found out. Epsilon 2, what we have to do for finding DCs of epsilon 2 plane, that is L2, M2, M2, consider. So consider this one. Now what you have to do, from the principal diagonal element, you have to subtract epsilon 2 now here. Epsilon x minus epsilon z, epsilon 2, epsilon y minus epsilon 2, epsilon z minus epsilon 2, remain other terms remain the same. Now repeat the procedure and proceed. Find out the cofactors A2, B2, C2. A2 is the cofactor of this, B2 is the cofactor of this, C2 is the cofactor of this. Now plus minus plus sign, and neglect that column. It convert it into a 2 cross 2 determinant, find its value. They are constants A2, B2, C2. Find out K2 using this formula. Then L2, M2, N2 are given by A2 by K2, B2 by K2, C2 by K2. They are the DCs of epsilon 2 plane. So second plane we have got. Similarly, for the third epsilon 3 plane, DCs are M3, M3, M3. So now we have to consider this one. So subtract epsilon 3 from the principal diagonal element. If epsilon 3 is negative, it becomes minus into minus plus. Be careful there. So whatever values you get here, same values you have to take, whether it is positive or negative. So be careful there. If epsilon 3 is negative, epsilon x minus into minus becomes plus. That value you have to take. So replace these principal diagonal elements by after subtracting that epsilon 3 from the respective elements. Other elements remain the same. As usual, find out the cofactors A3, B3, C3. So A3 is cofactor of this, B3 is the cofactor of this, C3 is the cofactor of this. So then A3 you find out, then L3, M3 are found. So this is the procedure to find the directions of the principal planes on which the principal strains act. So procedure is similar to principal stresses. So same, then instead of stress tensor, they will use strain tensor, and they will ask you to find the both principal strains as well as the principal planes or the principal directions at a point.